Hi everyone, this is a video about stationary points, which is one of the key concepts in calculus. Stationary points are where the derivative equals zero. They're sometimes called turning points or critical points. Turning points is a fairly good description of what they are, but they're not always turning there. And critical points can mean other things in other aspects of math. So we're going to stick with the term stationary points. Now, the derivative is the rate of change. So if the rate of change is zero, that means it's not changing. The y value is not changing. It's staying the same. It's stationary. Okay, every other point that has a derivative that's positive or negative will either be increasing with a positive derivative or decreasing. Three types of stationary points. One's minimum, maximum, or points of horizontal inflection. Okay, so at a minimum it goes from a decreasing to an increasing gradient. So with a maximum it goes from an increasing to a decreasing, and for points of inflection it's increasing to increasing or decreasing to decreasing. Okay, but at every one of these points here with the blue dot, they're stationary. Also, the gradient to each of those points is zero. So, because the derivative is zero there, so they'd have a horizontal tangent. Remember, the derivative is the gradient of the tangent to the point. Okay, a couple of key concepts are local and global. This down here is the very lowest point on the graph, so we'll call that the global minimum. This point here isn't the lowest, but for this little section around here, it is the lowest. So we'll call it a local minimum. Still, it's going from decreasing to increasing. There's a derivative zero there. There's the horizontal tangent to that point. So that's a local minimum. And this, of course, we call a local maximum. In terms of global maximum, we're not going to say there is one because these two lines, these two ends of the curve keep going on forever to infinity in both directions. Okay, so I hope you're asking two important questions now. How do you find stationary points? And once you've found them, how do you classify them? What type of stationary point they are? How do you know whether it's a maximum, a minimum, or a point of horizontal inflection? Of course, if you can graph it electronically on your calculator, you'll see it very easily. You zoom out to the right setting, you'll see it easily. If you don't have a calculator, there's two methods I want to show you. First is sign diagrams, or the first derivative test, and then there's a second derivative test. I'm going to show you that really quickly. Okay, here's an example. We're going to find and classify all the stationary points on this very complicated looking function here. Find as in what's the coordinates of the points, and classify as in is it a maximum, a minimum, or a point of horizontal inflection. We've got to remember that a stationary point's derivative equals zero. Okay, you see the keyword stationary points, you say okay, derivative equals zero. So you go zero, so you take the derivative. Easy derivative there, just using the power rule. Okay, put that equal to zero. Okay, now some of you might be really confused and concerned by this cubic here. You don't normally see cubics, you're not used to solving cubics, but some of you might already see something. 4 minus 12 plus 8. If you don't see that, take out the common factor of 4. Now 1 minus 3 plus 2. Did you recognize that x equals 1 is a solution? Yeah, so then we'll have x equals 1 as a solution, and by doing some nifty long division we can get that this was the other factor. You may not know how to do that yet. I have another video somewhere that will show you how to do that. High level students will need to know how to do that. Okay, but everybody should be able to factorize this now. Okay, factors of -2 that add up to 1 are 2 and -1. Okay, so we've got x minus 1 x minus 1, and x plus 2. So our solutions are x equals 1 or x equals negative 2. So have we found the points? Well, we found the x values. Put those values into the formula, you'll get the points. So there are our stationary points. Well done, we found them. Now what type of points are they? We're going to classify them. The first method is to look at the derivative on either side. Okay, sign diagram or first derivative method. Okay, now I probably should do this as one big straight line, but we're going to do it as two here to make my point. Normally in a question I'd put it together as one line. What happens when x is less than negative 2? Well, if you put a number less than negative 2 in here, you'll get a negative number. There's an example. Okay. So that's going to be a negative number. If you put a number bigger than 2 in here, negative 2 in here, sorry, you get a positive number. Okay, you can trust me on that, or you can put other numbers in to see if that works. Okay, now what you notice here is it goes negative slope, zero slope, positive slope. Okay, what does that look like? It's a minimum. So if you see negative, positive, that's a minimum. Okay, if we look at the other side, okay, if we look at less than 1, it's going to be the same as what we had over here, so that's going to be positive. If we look at a number greater than 1, okay, so, well, 4 times 1 plus 8 is 12, and minus 12, so you think you can work out pretty quickly that numbers bigger than 1 are going to be bigger than 0. So you're going to have positive there too. So it goes from a positive to 0 to a positive, so that's called a point of horizontal inflection. And just checking on our picture, there's a minimum there at x equals negative 2, and a point of horizontal inflection right there at x equals 1. Okay, so that's a good method, works every time, nice and simple, but maybe takes a bit longer than this next method. Okay, we can classify using the second derivative test. So you take the second derivative, and then when x equals negative 2, the first derivative is 0, but the second derivative is positive. That means it's a minimum. It's positive because it's going from a negative slope to a positive slope. So the change in derivative is positive. So this is the change in derivative. With the other one, you put x equals 1 in here, you get the first derivative 0, second derivative is 0. So the derivative's not changing. The slope's not changing according to this, which means it's a horizontal inflection. Okay, that was a really quick example of the second derivative test. You might like to look that up a bit more. Alright, hope this was helpful. All the best.